So here we are again with a new script. We still have the additive setup over here to the left. And then we've got this new setup over here called simple subtractive method. Once again, you can see that I've pulled in a setup that I've labeled as flawed because there are some issues with it. And once again, it is an actual setup that I've seen in production in the last couple of years. Just adjusted for using, my render and, my AOVs for this, purposes of this demonstration, of course. But the gist of it is the same as an actual setup. So I think that we're going to do the same thing as we did before. We'll walk through the setup and we'll analyze it. We'll find out how the method works in principle, what is good about the setup, and maybe what is not so good. And then after that, I'll show you a very similar setup with any necessary fixes, just like before. So let's just jump in and do that. At the first, we're looking here at our CG in. Actually, let's go up for a second. Let's turn on the variant with this kind of an alpha. And then we can look over here. So we've got the CG in. We are shuffling in our beauty RGBA over here. So that's in the stream as well. And then we're doing an unpremult. So if we're looking here, we are in premultiplied state with the renderer. And we're unpremulting. And this time we're unpremulting all passes. That means that if we look over here on these shuffle nodes, they should be unpremultiplied too, which they are. So that's all good and correct. In other words, the unpremult here is happening in the correct space or place. Then we can see that we've shuffled out 3 different passes. One is the high key or a key light pass. Here we have one called indirect glossy reflection. Then we have combined diffuse, which is here. Okay, and what's going on after that? As you can see, we've got each shuffle right behind it or below it is a keep node set to, or a remove node, set to keep and keep the RGB only, which means that we no longer have, oops, let's have a look here. We no longer have any of these other passes that we have. If you look here, we got all our passes over here, all our AOVs accessible. And here we've killed them. So that's pretty good because that is in accordance with the requirements that we had for keeping the data sparse. Remember, we did these requirements in the beginning. So far, so good, I think. This is looking pretty good. Now, let's move on. Because I guess here is where we get to discover exactly how this method, this subtractive method actually works. And why we call it a subtractive method, or at least why I call it a subtractive method. But first, let's jump back up here again and let's put ourselves back where we can see the backdrop, just because I like that image a little bit better. And I think if we look for a second here at the additive side of things, with the simple additive method or setup, what we obviously are doing is we're simply adding up all our passes in order to do the beauty reconstruction one time. With the subtractive method, things are a little bit different. We actually our starting point is with the beauty. Then we have to shuffle out any given AOV that we wish to actually work with. So that's basically we start with the beauty and then we shuffle out some information over here. And then we'll follow basically a 2-step process. The first step is that we need to take that information, this AOV, and subtract it from our beauty. So we go from beauty, then we subtract information. We're no longer at the beauty. And then we take that same information in the second step and we simply add it back again. So we're going beauty, no beauty, beauty. And that is, in a nutshell, how the method itself actually works, which means that we've done a beauty reconstruction with just one single pass, as opposed to in the additive method, where we needed all the passes to do the one reconstruction. And if we now take the AOV over here, so this part with a shuffle, plus this 2-step process with a subtraction and an addition. And for the lack of a better word, I'm just going to call it one segment for now. If we call this a segment, we can say that with the subtractive method, we will be doing a beauty reconstruction for every segment. And as you can see here, hopefully pretty clearly, in this simple example, we have 3 such segments. So this is the first one, then here we have the second segment, then here we have the third segment. So we are actually doing 3 beauty reconstructions in this setup. So let's think about that for a second. What could be the benefit of doing things doing things this way? Well, one benefit is since you're doing a reconstruction per segment, or each time you shuffle out some information in the form of an AOV, you don't have to shuffle out all your other passes for the reconstruction to work. In other words, if you only wanted to grade one single AOV pass, you would only have to create one segment, like here. So in the most possibly simple case, you have your beauty here and you say, maybe I think this render is a little bit too dark and I would just want to brighten it up a bit and then I'm done. I could take a grade node. And by the way, when we are grading here, we need to make sure that we're grading between the merge node up here, between the subtraction and the addition, but obviously not on the B pipe. We don't want that here. We want it here somewhere on the A pipe. So let's just do that. Let's have a look over here, reconstructed beauty, and let's say I'm just going to brighten it up a bit and take the gamma up a little bit, and now I have a brighter image. And if that's really all I wanted to do, then this segment is the only segment I would have to create in order to make that setup actually work. Another important thing that follows from this is that since we're doing the reconstructions per segment, it also therefore doesn't really matter from which specific AOV set the passes or the AOVs are coming from. And as you could see here, we have here a key light, which is part of the AOV set, which I call light groups. And then we have, again, the reflection here, which is part of, well, it says indirect glossy reflection, meaning it is part of this direction or directional slash indirectional light contribution AOV set. So there's like another set. And then over here we got the diffuse, which is a material AOV. So all of these things can actually be used in unison because we're doing the reconstruction every time we are shuffling out an individual pass. They can actually be used together, or you can say you can grade across these sets, which you can't easily do with this simple additive setup we showed earlier. So just to demonstrate that, I put a grade node in here as well. And let's say I wanted to increase the bounced light on my reflections, because that's basically what this pass is. I can simply do that by, grading this up, just adding a lot just to basically have a bit of a drastic effect you can see here. And now I have two grades. I have this grade here and this grade here, grading on two, or basically doing grades on two AOVs from two different sets of AOVs. And they both work in unison. So that's actually pretty good. This is definitely a pro with this kind of setup. On the con side of things though, you could argue that because we can shuffle out any passes in any order, things could maybe become a bit less well ordered or maybe less consistent in its layout, especially if the setup is larger and a bit more complex. So let's turn this off for a second. If we again look at our additive setup, so this is basically we picked the light groups for this, and we need to add all of these passes together, all of these AOVs together in order to do the one reconstruction. Okay, so let's consider a case where you have multiple artists working on many shots of a sequence. You've done sequence lighting on the CG, so your number of passes for each shot is the same, what they're called is the same, everything is kind of, consistent. Meaning, in this case, with the additive setup, it will be very simple for you as well. When everything is the same for each shot, you can set up, since you're shuffling out all the passes of these sets, you can set them up in such a way that the order is also always the same. So if, let's say you always want the environment light at the left side, followed by a key light, followed by fill light, etc. And that makes it very simple and easy for you as you work on shot after shot, and maybe also every single artist's work with exactly the same layout. And it's simple for them to then, as soon as you learn to know how exactly this functions is set up, to know exactly where to find your pass that you're looking for. Whereas over here, you can think about the same case, and let's say three artists are working on shots in the same sequence, and one artist may do their grade only using 2 sets. Another one might need 5 sets to do their shots. A third one might do 3 sets. And so basically you already have a bit of inconsistency if they're all setting their shots up exactly like that. And then the other thing is, of course, the order of which these AOVs are shuffled out might also differ from artist to artist. So again, that might be a slight con with the setup in terms of consistency. Now, you could, of course, do the same thing with the subtractive setup as you do with the additive setup, meaning that you set up all your segments, as I call them here, basically by shuffling out, let's say in one AOV set, you shuffle out all the AOVs, and you set up the subtractive process for every single AOV. And then you would have, basically, then you can also do the same where you do your layout in such a way that it's always the same, meaning any new artist could come in and easily understand and find things in the same way that it's easy to find them in the additive setup. You could do that, but then you forego the option that you have with the subtractive setup that you could potentially get away with less, or basically a smaller setup with less AOV shuffling, etc. So that means there's a trade-off you have to make. Do you want to make your layout really small, and easy with easy overview, or do you want to basically make it more consistent in terms of always having the same layout? In which case you might have to shuffle out all the passes. Again, that will be a trade-off. Okay, so far so good. I think we now know how the subtractive method works. Now let's get back to the reasons why I've labeled the setup as, if we look at here, as flawed over here. There are a couple of reasons why I think this setup here might still not be quite optimal. And obviously we're going to have a look at this. So we start, let's just get rid of those great nodes. The first thing that I can mention is something you might already have seen, as I'm moving around showing you stuff in the setup. You might have already have noticed it. But remember that we call these things here, like basically one of these sections, we called it a segment, and that we have 3 such segments in here. The first and the second one are built in pretty much exactly the same way, but we can see that we have an issue, or not an issue necessarily, but we can see that something is different here with this side of the last segment. So what's happening? Well, if we look over here, we have shuffled out our combined diffuse. So after this reconstruction here, we are going to remove that diffuse lighting from our beauty. Doing that here, but we're not actually seeing what we're expecting, which is all that stuff going away. It's only really affecting this part here, this little vegetable on the table. And the reason is very obvious, because of course we're using a mask input to the from, and we're again using the same mask input down here, because we use it up here, we have to do it here as well, when we're putting this information over here back into the B stream. And this is something that I can't really say that this is technically wrong, but I would definitely not prefer to have my setup done like this. I do think that we should actually try to keep these merge nodes, or the merge nodes over here, keep that as simple as possible and not use any masking on the merge nodes themselves. Because I think if this was a much more complicated or much more extensive setup, things could get a little bit confusing, maybe look a little bit messy if some of them have masks on them and others didn't. So that's one thing I don't quite like about that. And the other part is that, of course, you could achieve the same result. So, for example, if we're going in here and we're putting down a grade and we're grading up and down, you can see here that we're really only grading the, I think it's a turnip over here. That's the only thing that gets graded, but of course, we can achieve the same result by just keeping things simple over here and on our merge side of things, and then actually just use that mask that we're fetching from up here. So yes, it says turnip, and it's just basically a cryptomat mask. We'll look at our alpha, and we can just use that alpha directly on our grade node, which I would consider to be a much better way of working. Yeah, use the masks on the grades instead of on the merge nodes. So that's kind of the first thing that I would change in this setup. I don't really like the way that is done, but let's kill that and let's put this setup kind of back to where it was in a state like that. Yeah, so this I would change. Down below this, we then have a premult. So on the surface of things, that kind of looks correct. We are unpremultiplying up here. Then we're doing all our grading in an unpremultiplied state. And then we're premulting down here. The only thing, though, is that the next issue is that this is actually not correct, because there is in this setup, and again, this is from a production, so this is something I've seen out there in the wild. So below this premult, we have an overall grade section and a bunch of grades in here that are actually now grading in a premultiplied state, and that is wrong. So this I would consider to be technically wrong, and I think we need to do the same thing. Remember, on the simple additive setup, the first that I showed with its issue, one of them was that the unpremult node was in the wrong place. Well, and this time it's the premult node that is in the wrong place. We would move it down below the overall grade section, and then we should be good to go. So that is the second thing. And then the third thing is this idea of real estate for our grade nodes. So once again, the way that this is set up, and this is not wrong, but we can see here that the space that we have available for each of these segments is not the equal. So we have a lot more space to grade this segment here than we have for this one or this one. So this is a third thing. Again, not wrong, but this is a third thing that I would change or fix in the, as I said, fixed setup. So let's actually have a look at that setup then. So here we are again. I've opened up a new script containing our fixed version of the simple subtractive setup. And let's just have a look at the things I've changed and make sure I got everything done that I wanted. So for that, I guess we can zoom in a little bit, maybe just do this. Since we don't really need the main image for most of these things. I think there were like 3 things that I wanted to change with the flawed version that's over here that I showed you earlier. The first thing was the fact that I'm not a fan of using mask inputs on these merge nodes. I mean, I acknowledge that, of course, there are situations where you want to do this, but specifically for a CG setup like this, I would not want to do this. I would much rather actually prefer to have my masks on my grade nodes that I would put over here. So that's the first thing. As you can see here on the next side, we are starting here with our beauty, because that's our starting point in the subtractive method. And the B pipe is going straight down. Very, very clear to see where the data is flowing here. And I have no masked inputs into any of these nodes. So that's the first issue. The other one, which was also kind of an obvious one, is that this premult node was in the wrong place because we have this overall grading section over here. We need to put the premult node at the bottom like this. So that's done. And this is the fix for that. And then the third thing is a kind of a layout issue. So that's something we can do for just basically a bit of visual clarity maybe, but also essentially this real estate that, as I said, that we have for our grade nodes, which is now in this setup the same for every single, I think I called one of these things, these elements where we shuffle out and we do our from and our plus one segment. So each segment now has the same amount of space for your grading nodes, which was also not the case here. So this is more of a cosmetic thing, really, but one I would say is quite nice to have a, it also adds, in my opinion, to a bit more of a visual clarity. Things look a little bit better organized and ordered here. I have chosen to keep the structure here vertical. Because the setup that I showed over here has that. I could, of course, try and set up this section here in a more horizontal way that I've done over here by reorganizing things. But I do like in this sense that we have the B pipe going on top down, which was one of the earlier requirements, or not requirements, but at least a recommendation that I thought we should consider. So I chose to basically do this as a vertical layout. Now, one other thing is that you can see we have three shuffle nodes here. Each shuffle node is shuffling out a pass from a different AOV set. So this is a material AOV. The indirect glossy reflection would be the direct and indirect lighting contribution AOV, as I think I call them. And this high key is a key light, so that is a light group AOV. And you will remember that I talked about the fact that with the subtractive method, we have this benefit where we can actually grade across different AOV sets, because we are effectively doing, again, if this is a segment, we are effectively doing a reconstruction of the beauty for each segment. So then that gives us the option to grade across different AOV sets. But here, what I have done, as you'll notice, there are 6 shuffles, or, you know, if I zoom in, you can see what they are as well. We got the screen right spot, top fill. So basically these 6 represent exactly the same AOV passes that I shuffled out for my simple additive setup. And that basically goes to show that, of course, you can reconstruct you can set up your subtractive setup and method in the same kind of manner that you would have to do in your additive way here over here, where you have whole sections that represent a single AOV set, where you don't grade. Like in this setup here, you would obviously only grade on one AOV set. But what you could do here, if you decided you also wanted to grade on, let's say, your diffuse pass or any other material AOV, you could simply extend the stack further down. Just keep the exact same structure, and you can just basically extend it further down. But you can already, as I'm, just not even showing you, but already you can kind of see what that would lead to. It would lead to, in this vertical layout, it would lead to a very long stack, eventually, if you kept this structure. And that might be a bit of an issue in terms of just, you could quickly lose the overview that you have of your setup. It would be the same problem if you chose to lay these things out horizontally. You would end up with a very long stack. So how could you improve that? Well, I guess theoretically you can, or not theoretically, also in practice, you could go in and do a backdrop and label it something, like if I did that here, I would call them light groups. Let's make this visible, hopefully. So here we go. So now, and then you could add another stack below, or you could perhaps even just move it to the side over here with your material AOVs, for example. So there is definitely a thing to be said for further organizing this setup. I'm going to, I guess I can just leave it in and try to set things up in ways where you don't end up with a very sort of long tower or a very long row of things. But there is another thing that I wanted to see. I was wondering, well, I'm not wondering, I do know that there are ways of doing different setups from this. And that has to do with the fact that maybe we like the additive way. It's sort of simple. It also works kind of the way that your renderer does. Your renderer tends to basically just add these passes together. There are some exceptions with some passes where you need to do a couple of different operations in order to get them, but that's, a subject for another day. In general, your renderer will do additive passes because it was set up so that the AOVs are meant to be added together. So maybe you like this, but we also like the fact that we can grade across AOV sets. So then the obvious question is there a setup or a type of setup where we can combine these things? We can combine this kind of simplicity and ease of use of the additive setups with the added benefit of a bit more flexibility in terms of how we can, as I said, grade across AOV sets in the subtractive method. And yes, obviously there is setups, or there are setups that will do that for you. And I think, sorry, and I think that's basically what we will start with in the next section. So thank you. Let's just go back out here like that. We see our image one last time, and then we move on to the next section.